Yeah, good morning to all of you. In this lecture, I will discuss about the concept of Gauss law. In the previous lecture, we have already discussed that what is flux, how to calculate the flux in different situations. So, in this lecture, I will discuss about the Gauss law, what is Gauss law, and statements of Gauss law. So, Gauss law in electrostats states that the flux through any closed surface is equal to the charge enclosed in that surface divided by free space permittivity. So, it states that is equal to the charge enclosed divided by free space permittivity. So Gauss law simply states that the flux through any closed surface is equal to the charge enclosed in that surface divided by free space permittivity. So mathematically we can write it as flux through any closed surface is basically E dot ds if there is a surface as, so E dot ds is simply charge enclosed in that surface divided by permittivity, free space permittivity. We know what is epsilon g. So this is the integral. We can say that this is the integral form of Gauss law, which tells us the physical significance of this mathematical expression, tells us the physical significance of Gauss law, which states that flux through any closed surface is equal to charge enclosed in that surface divided by free space permittivity. And we have a differential form so this is integral form and we have a differential form which is del dot E is equal to rho by epsilon 0, or we can write it as divergence of electric field is equal to rho by epsilon 0, where rho is charge density and epsilon 0 is, you know what is epsilon 0, which is free space permittivity, and its value is 8.85 10 to the power minus 12 coulomb square per Newton meter square. So these are two different forms of Gauss law. So in differential form, we can find out the charge density. If we have information about the field, we can easily find out the charge density. Or if we have information about the charge density, then we can easily find out the electric field. And what is this del? This del is known as dEf del. This is simply mathematical operator. This is which is defined as, this del is I del by del x, j del y plus k del by del z. This is in Cartesian coordinate system. We have different profile of this depending upon the choice of coordinate system. If we are dealing the Cartesian coordinate system, if we are dealing our system in Cartesian coordinate system, then this del is simply I del by del x plus j del by del y plus k del by del z. If we have a spherical polar coordinate system, so we have different profile of this del. If we are in cylindrical coordinate system, then we have a different profile of this del. So you may, this is just a home assignment. This is Cartesian. Write the expression of del in spherical polar coordinate. Also write the expression of del in cylindrical coordinate system. in order to find out the nature of electric field in polar and cylindrical coordinate system. So this del dot E is equal to rho by epsilon 0. This is known as differential form of Gauss law and this is known as integral form of Gauss law. And this rho is charge density. And this one is charge enclosed divided by, we have a separate concept of charge enclosed, that what is charge enclosed? What is charge enclosed? If we have, consider if we have a charge, let's say Q1, Q2, Q3, Q4, Q5, and if you close the contour, let us close this contour, that so what is charge? What is the expression of charge enclosed? Let me just, this is figure A, and write down the so this is a statement question or objective question. Someone asked, if we have a situation like that, if we have a charges Q1, Q2, Q3 as indicated by this figure, so write down the expression of charge enclosed. So this is very important concept, charge enclosed and current enclosed in electrostat and magnetostat. So charge enclosed. So what is Q enclosed? So Q enclosed in this case is simply Q1 plus Q2 plus Q3 plus Q4, not Q5. Charge enclosed means total charge enclosed are within the surface or onto the surface. So in this case Q5 is out of this loop, out of this closed surface. So Q5 is not come into the picture of this charge enclosed concept. So write down the expression. So this is the correct expression of charge enclosed. If we have many charges, in previous cases we had, if we have a single charge, so that is okay, no problem. But if we have a many charge system, so the charge enclosed is defined in this way. So next we will discuss the validity of Coulomb's law, and basically the objective of this lecture is to discuss the concept of Gauss law. What is Gauss law? Its differential and integral form, and concept of charge enclosed, validity of Gauss law and application of Gauss law. So validity of Gauss law. So again this is a statement question in objective examination. In any objective type examination, that validity of Gauss law. So whether Gauss law is valid for all surfaces or it is valid for few surfaces. So Gauss law is valid for all surfaces, but it is useful for symmetrical surfaces. So Gauss law is valid for all surfaces, but it is useful for symmetrical surfaces. So generally we have three different kinds of symmetry in nature, that is spherical symmetry, cylindrical symmetry and planar symmetry. So we have three different kinds of symmetry. First, spherical symmetry. Second, cylindrical symmetry. And third, we have a planar symmetry. So this is the information about the Gauss law, that Gauss law states that total flux through any surface, closed surface, charge enclosed in that surface, concept of charge enclosed, that if we have a q1, q2, q3, q4, q5 charges, then corresponding to this situation or corresponding to this particular figure, we have total charge enclosed in this surface is q1, q2, q3, q4. q5 is out of this surface. This is not within or onto this contour. That is why this charge enclosed is only the sum of q1, q2, q3 plus q4. And validity of Gauss law. So Gauss law is valid for all surfaces, but it is true for Gauss law is valid for all surfaces, but it is useful for symmetrical surfaces. So we have three different kinds of symmetry. One is spherical symmetry, another is cylindrical symmetry, and third one is planar symmetry. Next we have application of Gauss law. How to apply Gauss law. So there are few steps, and let me explain or write. These steps are as follows: that identify the geometry, or identify the problem, recognize the geometry, and then see, in these three kinds of symmetry we have three different Gaussian surface. Corresponding to these three different symmetry we have three different Gaussian surface. For spherical symmetry we have Gaussian sphere, and in other words we can write it as this is concentric sphere. And so we have three different kinds of symmetry. Spherical symmetry, corresponding to spherical symmetry we have concentric, we have a different Gaussian surface. So in spherical symmetry we have concentric sphere, and in cylindrical symmetry we have coaxial cylinder. The Gaussian surface is GS symmetry and corresponding Gaussian surface. So this is coaxial cylinder, and this is Gaussian pillbox. So these are very important points. In Gauss law is valid for all surfaces, but it is useful for symmetrical surface. We have three kinds of symmetry. One is, and corresponding to these three different kinds of symmetry we have three different Gaussian surface. We have three different Gaussian surface. So corresponding to spherical symmetry we have concentric sphere. If we have a cylindrical symmetry, so corresponding Gaussian surface is coaxial cylinder. If we have a planar symmetry, if the charge is distributed along the plane, so in that case we have a planar symmetry. So corresponding Gaussian surface is Gaussian pillbox. So this is again statement or objective statement questions. So how to apply the Gauss law or application of Gauss law? So Gauss law is used to find out the electric field. So how to apply Gauss law? So there are few steps through which we can find out the electric field, or through which we can apply the Gauss law in order to find out the electric field. So first is identify the geometry or recognize the geometry. Draw corresponding Gaussian sphere, Gaussian surface. See. So first one, identify the geometry. Second, draw the corresponding Gaussian surface. Third, find charge enclosed. find total charge enclosed. Total charge enclosed, then evaluate E dot ds, and then fifth one is E dot ds, then rearrange the whole expression. Rearrange the LHS and RHS, that is E dot ds q enclosed by epsilon t, and find E. So this is 4 to 5 step process through which we can find out the electric field using Gauss law. The first, identify the geometry, draw the corresponding Gaussian surface, then find total charge enclosed in that surface, then evaluate the left hand side integral, that is E dot ds, and which is equal to q enclosed, and rearrange to find the E. So this is 5 step process through which we can find out. I think it's all about the Gauss law. What is Gauss law? Its differential form, its integral form, concept of charge enclosed, and then validity of Gauss law, and symmetry and corresponding Gaussian surface. So we have 3 different kinds of symmetry, and corresponding to these 3 different symmetries, we have 3 different kinds of Gaussian surface, and these are the steps through which we can apply the Gauss law in order to find out the electric field. So it's all about the Gauss law. In next lecture we will discuss about few examples to evaluate the electric field using Gauss law. Thank you.